Good day once again. My name is Graphics. Today we'll be looking at another topic in strength of material, which is talking about slope and deflection of beam. Now let's consider this beam. It has two reactions. It is a simply supported beam. It has two reactions. Let's say arrow AY and what? Arrow BY. Now let's say there's a load, which is the weight on it. Now probably the weight is more than the beam can bear, and on that process it bends the beam, right? It bends the beam. So the distance between the beam before and after loading is called Y, and Y is what we call the deflection. So we define the deflection of the beam, the deflection of beam, as the vertical distance between the beam before and after loading, right? Or we say that it is the vertical displacement of a point on the loaded beam. So you can say it's the vertical displacement of a point on the loaded beam, and the point can be anywhere on the what? On the beam, right? So now if you look at this now, an angle is formed here at this edge here. We'll call it theta, and it's giving us what? Our slope, which is the y over what? The x, right? So that is our slope of the beam. Start again. And the slope of the beam, our slope of beam is defined as the angle between deflected beam. This is the deflected beam here. So the angle between deflected beam to the actual beam. So the deflected beam to the actual beam, that is what? Our slope. So I can write as the angle between the deflected beam to the actual beam at the same point. That again. Now let's take a very good illustration on how to calculate the slope and deflection of beam of a beam. Slope and deflection of a beam. Now, example. We have some boundary condition that we apply whenever we're talking about slope and deflection, right? We know very well that the deflection of a beam is maximum at half the distance of the beam, and we know the slope is maximum at the beginning of the beam and at the ending of the beam. So as we solve examples, I will expose you to some of these boundary conditions. So example 1, let us consider this beam. Let us consider this beam. So it has a weight on it, which is called W, and we have the reaction here at point A. I will call it RAY. We have the reaction here at point B. We call it RBY, right? The distance between point A to point B is given as L, and distance between point A to this middle of here is given as L over 2, and from here to here is still L over 2, right? So like I said earlier, to calculate such a beam, the first thing you have to do, you need to calculate for what? The reaction. So we write that calculating for reaction, we use our condition for equilibrium. Now the first condition is the summation of f of x equals to what? 0. So we are going to consider forces to the right to be what? Positive, and forces to the left as negative. But in this case here now, there is no horizontal component. Now the next thing is the summation of f of y equals to 0, and we are consider upward force to be positive and downward force to be what? Negative. So our two upward force we have here is RAY and RBY. So we have my RAY plus my RBY, and the downward force is facing down, which is W, and that is negative W because it's facing down, equals to what? 0. So in this case, we say the RAY plus RBY is equals to what? W. I will term this to be the equation 1. Now the next thing we do is taking moment, summation of moment about point A equals to what? 0, and we consider the clockwise moment to be positive and the anti-clockwise moment to be negative, right? So from here, since you take moment about here, this force here will be coming towards the direction, and that is clockwise. So it will be W force times the perpendicular distance, which is L over 2. So we have plus this coming in this direction, and that is anti-clockwise. So it will be minus RBY times distance of here where the force is to where we take moment, and that is from here to here is what? Is L. So we have L equals to what? 0. Now from here we'll be having the WL all over 2 equals to what? RBYL. Now if you divide both sides by L, my WL all over 2L is equals to what? RBY. Divide both sides by L. So we're going to be having L will equate L, so the RBY will now give me W all over 2, right? So from here we've done that. Now the next thing is to put RBY in equation 1. So substitute ROBY in equation 1. So my equation 1 is telling me ROAY plus ROBY equals to what? W. So the ROAY plus W all over 2, so our ROBY equals to what? W. So from here we now have from here we'll be having the ROAY equals to W minus W all over 2. So if you look for the LCM here, the LCM here will be my ROAY will now be equals to LCM is 2. So if I bring 1 into, will give me 2 times W will give me 2W, minus 2 into is 1 times W will give you W. So in the long run, my ROAY is equals to what? W all over 2. So we have W over 2. Now what we are going to do here is this, getting ROAY and what? ROBY. So now we have successfully gotten the reaction. Now the next thing is to get the slope and the deflection of the beam. So what I'm going to do is that what? I am going to section one end of the beam, right? So the distance between that end of that beam to this point, we are going to term it X, right? So we are taking the moment about the section XX. So what I'm actually going to do here, I'm going to say that the moment about section XX, right, will be, this guy is going this direction, and that is anti-clockwise, right? So and that is negative, so it will be minus W over 2 times X, right, equals to what? 0. Because let me put it this way, MSX plus minus W over X equals to what? 0. So if I take this here, my moment about section XX will be equals to what? WX all over what? Over 2. But the moment about section XX is equals to what? The Young elasticity multiplied by I, then we have the square Y all over what? The X squared, right? So anywhere I see my MXX, I will replace it with what? This. So we're having E I the square Y all over the X square will be equals to what? WX all over what? 2. Now what I'll do here is this. I am going to call this my equation 1. So if I integrate, I'll be having EI the Y all over what? The X, and that will give me the integral sign of WX all over 2 dx. So if I integrate this, the EI dy all over the x will give me, if I take my constant out, we have w all over 2, so left with integral x dx. So from here, the EI dy all over the x will give me w all over 2 into bracket s squared over 2, then plus c, call it c1. So from here, the EI dy all over the x will now give me wx squared all over 4 plus c1. I'll call this equation what? Equation 2. Right? So in this case, applying boundary condition to equation 1. Applying boundary condition to equation 1. So applying boundary condition, you say that at x equals to what? At x equals to what? L all over 2, then the y all over what? The x is equals to what? 0. So what it's telling us is that what? If I travel half this distance, at this distance here, there is no slope. It is just a uniform line. So at the half of this beam, the slope is what? 0. So that is why at half of the beam, the slope is what? 0. So we move forward. So from here, we'll apply it here. So we'll be having EI times 0 equals to W. We have L over 2 whole square, everything all over 4 plus C1. So this will give me 0 equals to WS square all over what? 4 times 2 squared plus C1. So because this 2 square, when you have WS square this way, WL over 2 to the square here, right? So let's just proceed. So from here, I'll be having 0 equals to what? WS square all over 16 plus C1. So the C1 here will now give me negative WS square over 16. So I will now substitute my C1 in equation 2. So put C1 equals to negative WS square over 16 in equation 2. So we now have EI dy all over dx equals to WS square all over 4, so minus WS square over 16. So this, you see, is termed our slope equation. This is what we call what? Slope equation, right? So that is how that's our slope equation. Now that's not all. We proceed at For we to get our maximum slope, for maximum slope, x is equals to what? 0, right? For maximum slope, x is equals to 0, because if you check here, our slope is maximum at point A and at what? At point B. So at x equals to 0, we have our maximum slope. So from here, we'll see that anywhere we see the x, we put 0. So I'll be having my EI, the y all over the x is equals to w bracket 0 square all over 4 minus ws square over what? 16. So from here, we are going to be having this. So from here, we'll be having EI, the y over the x will give me 0 minus, because everything here will be 0, 0 over 4 will give you 0, ws square over 16. So from here, if I divide through by EI, so my dy all over what? The x is equals to what? Minus ws square all over what? 16 EI. So that will be my maximum slope at x equals to what? 0. Now, integrating equation 2 again, from equation 2, which is this equation here, we want to integrate it again. So we have EI dy over the x. We're having EI the y all over the x equals to wx square all over 4 plus c1. So if I take my x to this side and my y to the other side, I'll be left with EI y equals to what? The integral wx square over 4 ws square over 4 plus c1 into bracket what? dx. Now from here, my EI here, if I open the bracket, the EI y will give me integral ws square over 4 dx plus integral c1 dx. So if I take the constants out, I will have the EI y equals to w over 4 integral s squared dx plus c1 integral dx. Now from here, if I move forward, the EI y will give me, when you integrate this, we'll be having w over 4 into bracket, we'll be having s cubed over 3 plus c1x plus c2. So this will give me EI y equals to ws cubed all over 12 plus c1x plus c2. Now in this case, we know both c1 is equals to this, or c1 is giving us minus ws square over 16. We have minus WL square over 16. So you input it here. So we have in EI y equals to WS cube over 12 minus WL square x over 16 plus C2. So to get C2, we get the C2 here. We'll say applying the boundary condition to calculate for C2. We'll say where x, and put it applying boundary condition. You say when x is equal to 0, y will be equal to what? 0. How did I mean here? If you check this from here, this is 0, this point is L. When x is 0, there is no deflection at the edge of the beam because the deflection is at the center here. So at the end of the beam, our deflection is 0. So when the distance is 0, the deflection is what? 0. So you put it here. So I'm going to be having E I times 0 equals to W0 cube all over 12 minus WL squared times 0 all over 16 plus C2. At the end of the day, everything here will become 0, 0, 0. That is, this time is to give me 0 is equals to 0 cube is 0 times W is 0, 0 over 12 is 0 minus 0 plus C2. So we'll say the C2 is equals to what? 0, right? So now we'll now write this equation and says that the EIY is equals to WS cube over 12 minus WL square x over 16. So this is my deflection equation here. We call this the deflection equation, right? So to get our maximum deflection, for maximum deflection, we'll say that x will be what? L over 2. So L over 2, it is where the deflection is what? Maximum. So if you move half of this is L over 2, the deflection is maximum there. So what we'll do here is we'll be having EI y equals to, now W, our x is what? L all over 2 to the power of what? 3, everything over 12 minus WS square into bracket what? L all over 2, everything over what? 16. So from here, the EI y will now give me WL cube all over what? 12 times 2 cube minus WL cube all over what? 16 times 2, because L squared times L will give you L cube. Then the 2 will come down here. Now L cube, then 2 cube, the 2 will come down here. Now we're having this. So from here we'll now have this that says that EI y will now give me WL cube all over 12 times 8. 2 is power 3 is 8. 8 times 12 will be, that will be 96 minus WL cube over 32. So from here we're going to be having this. We're having this. That says that the LCM here is 96. 96 and 96 is 1 times WL cube gives you WL cube minus 33 and 96 is 3. So we have 3 WL squared. So we have this. That is my EIY equals to this. So from here, this minus this will be left with EIY equals to minus 2WL minus 2WL cube all over what? 96. So in this case, 2 in here, 1 in 96 is 48. So from here I will say that EIY is equals to what? WL cube over 48. So if I divide through by EI, so my Y, which is the maximum, will give me WL cube all over what? 48 EI. So that is the negative there. So this is my maximum deflection of the beam. So thanks for watching. We'll see in other related videos. Don't forget to click on the subscribe button and like my video. Bye for now.